This is the second in a series of videos in which I'm attempting to resurrect this MADAS mechanical calculator. We had a quick look at it in the first video. It seems to be jammed up partway through a calculation. I haven't tried taking this apart yet, I haven't cleaned it. This is just exactly how it turned up. There were various pieces missing. We may look at trying to fabricate some missing pieces. It depends how far we get through the repair. And as I said, this was made a little over 100 years ago, so it's a very old machine, very solidly made. It's all cast iron and brass sheet. I believe this is the model 9E metallic, and I'm not quite sure what the metallic stands for, but I believe the 9E is because it has 9 slides and it's electric. I think that's what the 9E stands for. And as I said, this is motor driven, very heavy. It weighs, I guess, around sort of 15 to 20 kilos, so quite a hefty piece of machinery. And the first thing we need to do is obviously get it apart. It seems to be jammed. Now the drive gear down here does turn, but I don't want to try spinning this around because I don't know quite what state the machine is internally. I don't want to start turning the drive shaft if something's bound up. I can't move the slide, it does seem to be stuck, but we should be able to get this off fairly easily. Now I've only ever worked on one of these before, and that was quite some time ago, so it'll be a bit of a learning curve as we go through this. Having said that, all mechanical calculators work on the same basic principle in that you have a series of selectors, and you set these, or use these to set a number for one of the inputs. And what this part of the machine does, it sets the number of operations that will be repeated for each column. Later machines had a key panel here, and all they really did is when you press the key, it effectively put the slide into one of 10 different locations. This is obviously a mechanical version where you just move it by hand into the location that you want. There are some pieces missing, as I said. This is loose. This is not critical for the operation of the machine. This just is a slide so you can set the decimal point markers. There is one missing from the second row. We may fabricate one of those if we can get the machine to work. But the first thing I want to do is get these off so they don't get further damaged, and then we'll try getting the main front lower panel off. As I said, these all tend to work the same way, so in theory we should be able to lift this panel off once we've taken all the screws out. Now someone has been here before me. Some of the screws are missing, some are loose, so I don't know quite what the state of play is and whether somebody had a problem getting this off. Or if there's nothing inside, we don't know. We'll have a look and see what we find. But first thing I'll do is get the decimal point slide rails off, if we can get these out. Now, one thing I've said before when dealing with old machines like this, it's worth spending half an hour getting a single screw out rather than shearing it off, because if you shear it off, you can easily spend several hours trying to get the stub out. And then having to make up a new screw or try and find something that fits. Okay, so I'll get these two rails taken off and out of the way, and then we'll get back on camera and see if we can get this front panel off. Okay, I've got the decimal slides out of the way. Next thing is I'll remove all the main screws that hold this front panel on and see if we can get the front panel off. What I normally do with machines like this is try to reset any parts that will reset. So if we can reset these slides, then it's going to put them hopefully in a position where this front panel will lift off. And then we need to remove anything that's going to be attached to any shafts that protrude through the front panel. So this is you can usually tell which ones are which. This one down here, you can see that the entire diameter of this control fits through the opening on the panel, whereas this one is wider than the slot, so chances are we'll need to take this one off, and same with these, but they should just unscrew, which luckily it does. It's not too tight. have my usual pot for all the parts to make sure I don't get anything mixed up. And then what we can do is take the screws out. As I said, most are missing. There should be one here and one here. They're both gone. We've got one up here, and I believe that's another one we will need to take out. So I'll get this one out of the way first. There's one over on the right here I'll take out. Tend to leave the middle ones till last so that the entire panel isn't trying to pivot down on the corners. And one here. And luckily they are all coming out very easily. As I say, I think these have been out previously. Okay, I think this one's stripped, which it is, so it's not coming out. I can't see any other screws, so in theory we should now be able to lift this front panel off. And there's probably a spring attached to this. It has to be attached to something else, otherwise of course it wouldn't spring back. But let's have a look and see what. So there we are. Okay, just need to unhook the spring. Okay, so that's all that's on the back of these. It's just a series of slides where a pin sets the location for the particular digit, and as I said, the ones with the keys on working exactly the same way, except that the key, when you press it, moves a slide into one of the preset positions. Okay, so this obviously will need cleaning and lubricating, but it does all appear to be there, so that's a good start. Okay, the next thing that we see inside are these appear to be brass drums. They are in fact pinions, and the way pretty much every one of these mechanical calculators work is there is a series of these pinions, these drums, and what they do, you can just about see it on this one, is it's kind of a gear where each of the teeth is a different length. So the first tooth is the full length of the pinion, the next one is a bit shorter, the next one's shorter still, etc. And the whole purpose of these is when you take this engaging gear and put it in one of the positions as set by the slides we've just looked at, depending on where you position this, it will determine how far this will turn with one complete rotation of the drum. So if it's set at the top, then it will engage with just one tooth on the pinion, so it will only move by one position. If you slide it all the way down, it will engage with every tooth on the drum and it will do a full rotation. So depending on where it's set will determine on effectively what count this particular column will increase or decrease by. And that's how the machine works. It just processes every column separately, and based on where these gears are, it will add or subtract a certain number. So if you put it into the 5th position, it will add or subtract 5. In other words, it will repeat this particular process 5 times. Okay, so it all seems complete so far. I can't see anything at the moment missing. Okay, and it is part way through a calculation. We can see this because these two drums are partly turned. What I'm going to do is take the drive off the end, or the drive cover off the end. Just need to move it across. One thing I did notice, this has, or supposed to have, rubber feet on the bottom. I've noticed that it's got one missing, and the other 3 feet are all different. So it's had quite a colourful life by the look of it. Okay, we should know how to move this, or remove this cover. There should be a belt and pulley system underneath. We'll take this cover off first. This is just a shroud for the motor. So again, no part numbers or model numbers on there. Try and take these thumb screws off. Okay, as we can see, the belt has seen better days, so we'll need to find some sort of replacement for this. Actually looks like a leather belt, and yes it is. We can see where it was originally joined, so it's snapped where the staples went through the belt. So this is very similar to the big belts you used to see in factories, just on a small scale. Okay, so this part down here is just a drive that makes the machine run. So this is where it takes an input from the motor. There's no other connection to the motor. This is just done all through this belt. Comes down to here. This is a mechanical drive. There needs to be a gear on here to drive this, and obviously that's missing. But what it does mean is I can try and rotate this and very carefully try and get it back into the end of cycle position. If I can get it into the end of cycle position, we can safely remove the rest of the mechanism without doing any damage. You can get it apart anyway, but it's just far easier if you can get it into the home position, because then it's much easier to realign everything. Unfortunately, 0 won't work when it's halfway through a cycle, so I do need to try and drive this manually all the way through the current calculation, whatever that might be. So what I'll do is try rotating it. I can't use the vernier wheel. I need to, because there's no gear on here, so I need to try and rotate it here. You can see the drum is rotating, and if we can get it to go all the way to the end, then it should finish the operation that it's trying to perform. Okay, so it is jammed somewhere. It is moving, but they're out of step. So we'll keep going and see if we can figure out where it's jammed. What I'm going to do is get the camera out of the way. I'm going to keep rotating this and follow it back through. There's a series of some shafts that run the length of the machine, and the bottom one is responsible for processing all the shafts that run up to these numbers. So I need to try and figure out if they're all turning and going back to their home position, and I need to be able to get the machine to 0. I don't want to take this top cover off until I can do that, because otherwise I'll have a major problem trying to reassemble it. Okay, so I'll get the camera out of the way, and as I say, all I'm going to do is keep running it through manually until I can figure out exactly where it's jammed up. Okay, so it was indeed stuck partway through a calculation. It was partway through a division, so the automatic division mechanism was stuck. Looks like we've got a broken part that we need to look into down here. It's not properly engaging. It is now freed up, so I can 0 everything, and it's managed to run right through to the end, and the return lever has disengaged. So when you push this down, the motor's normally running, you push this down to start the operation, and it engages the mechanism, then it stays engaged until it's finished the entire process. It looks like what may have happened is someone pressed this down, and the belt snapped partway through the process, and then it just stopped, and the whole thing then sort of jammed up and was left like that for a very long time. So this now works. It needs lubricating. It's all very tight, but it does now properly engage in both multiply, divide, add and subtract operations. It's just not going to allow me to set the division ratio. But everything else works. It's very tight trying to turn this, so I don't think this would turn even if we put a belt on at the moment, so I do need to try and get it all freed up. It's probably just grease needs cleaning out and lubricating. As I say, we'll now reset both the top and the middle rows, so what I can now try and do is get the mechanism out of the case, and once I've done that I can flip it over, give it all a very good clean, and then try and lubricate it. I probably won't take it completely apart unless I need to. We'll see how far we can get it clean, but I do need to look at this part of the mechanism here. It's not working the way it's supposed to, and I've got a feeling there's some other missing parts, and we'll need to see if we can source those. But all the numbers now rotate. Some are quite tight, so we'll need to try and figure out why they are not spinning freely. But they look to be in good condition, just very dirty, but they do all turn, so that's good. Not only do they turn, but also the reset lever does successfully set them all to 0 apart from this one. So I'll need to look at why that's not properly zeroing. And this is obviously one that you can't set directly. It's a kind of intermediate result, but I'll need to see if that will reset as well once we can drive it. So next step is try and figure out exactly how to get this out of the case, and then I can get the mechanism properly cleaned up, and then from there look at trying to resurrect it. Okay, so just one screw and the mechanism lifts out. So what I can do is get the outer case out of the way. It needs a really good clean, it's absolutely filthy inside, and we'll pull the mechanism forward and have a quick look at it. Okay, so that's the underside of the mechanism. We can see the stepped pinions, and they're all nice and free, none are bound up. So it looks like there's no severe damage in here. I can get to this well enough that unless there's anything broken, I shouldn't need to completely dismantle it. If we do need to dismantle this, it's not too difficult. You can just take this front plate completely off, and as long as you keep all the parts in the right order, then you should be fine. Some of these are different, so you don't want to start mixing them up, otherwise the machine will do all sorts of weird things. I'll just tip it on its front so it's the right way up. I still haven't found a model number, by the way. And it does appear that there are at least a few parts missing from the divide, the auto divide part of the mechanism. So I don't have a manual for this. We'll need to try and figure out what parts are missing and then perhaps fabricate some. If you do have a manual for this, or even just some photographs of the inside, then would be much appreciated. I just need to see how this part of the mechanism is supposed to be arranged. I don't think this is right. I'm pretty sure there should be something else going on here, and this does protrude through the front panel, so I think there might be a knob missing off here as well. But there's a post here with nothing on it. There's a hole through, so it looks like there maybe should be a spring on there. But it does appear that there should be something that deals with this, but there's nothing on the inside of the front cover, and this doesn't seem to do anything, just flopping about here. The rest of it seems fine. I might take this top front cover off to be able to clean it, and also to be able to clean all the number wheels. It's easier doing it with this front cover off than with it in place. Comes off quite easily. It's just a few screws and then unscrew the knobs as we did with the front panel. All the rest of it seems to be in fairly good condition. We will need to think of something for the drive gear. As I said, the front part of the drive gear that links the right angle drive through to the main drive is missing. I might have to cut a gear if I can't find one. I've got plenty of small gear cutters, and we can make a nice brass wheel for that if we need to. The rest of it seems fairly good condition. It's a bit sticky and needs a good clean and lubrication, but other than that, I think we should be able to get this back to how we'd like it. It is just really a case of trying to get the division to work. So, as I said, if you've got any close-up photographs or some information on what normally sits in this area, then it would be much appreciated. In the meantime, I'll get on with giving this a good service and clean, check all the springs, adjustments, and make sure everything rotates and slides freely.